Hi, today we're going to be looking at triangles and slope. When you completed your Notice and Wonder, I hope that you noticed that we have a slanted line. That means it's not horizontal or vertical. And we have 3 triangles. I hope you noticed that each triangle has a vertical side, that means up and down. And that each triangle has a horizontal side, which is straight across. You may have noticed that all of those triangles have their slanted sides right along the line. You may have wondered if the triangles are similar. You may have wondered if it matters that one triangle is kind of nested inside the other. So we're going to record information in an organized way in this table to see if we can identify a pattern. So the first one is done for us. We have triangle ABC, that's the middle-sized triangle. The length of its vertical side is 3. We get that right off the triangle. The length of its horizontal side is 4. We get that right off the triangle. And the third column asks us to compare the vertical and horizontal sides by division. In other words, write a ratio. So if we put 3/4, it is a ratio, which also means division. And then we can change it using a calculator or scratch paper, and it comes out to 0.75. So 3/4 is equal to 0.75. We're going to do that for each triangle. So the largest triangle is triangle CDE, and its vertical side is 6, and its horizontal side is 8. And if we compare by write as a ratio and compare by division, that's 6/8, which also equals 0.75. We have one more triangle. It happens to be inside the largest triangle. It's the smallest triangle, FGH. But like the other triangles, its slanted side is right along our line. So its vertical length is 1.5. Its horizontal length is 2. And if we compare it by division, write it as a ratio, it's 1.5/2. And that also equals 0.75. So hopefully you notice that this ratio, this comparison, is always the same for any of these triangles that are along the slanted side, along the slanted line. We call that slope. And because this ratio is the same for these triangles that are along the same line, those triangles are going to be similar. So if we put it in fancy math words, when we have a non-vertical and non-horizontal line, we can construct triangles on that line. We had 3 given to us. The quotient of the length of the vertical side and the horizontal side will always be the same. This is called slope. We're going to be working on slope for the rest of the period.